Hey guys, welcome back. Today we are continuing our unit on motion by talking about the difference between distance and displacement. So without further ado, let's go ahead and jump into this lesson. So when we describe motion in one direction, we use a reference frame. So this is from our lesson from yesterday. This describes the orientation of the object's position, distance, speed, and or direction. So remember, if you have a car that's passing by you at 50 miles an hour, from your frame of reference, the car is going 50 miles an hour because you are a stationary point. However, if there is a car that's driving next to it that's going 45 miles per hour, in reference to that car, the other car is only going 5 miles per hour because it all depends on your frame of reference. So just remember that's the orientation of the object's position, distance, speed, and or direction. So that's just a little review from yesterday. Coordinates are a chosen frame of reference, and sometimes they're labeled as X, Y, Z, I, J, K. This is common in physics. So with physical science, this course is kind of a mix of both chemistry and physics concepts. We've done a lot of chemistry in the beginning of this course, and now we're getting into more physics with motion, things like that. So how far does the Earth travel in 1 year? So stop and think about this, because I know you have all had Earth science before. That's your 9th grade science. We know that the Earth spins on its axis and it also revolves around the sun. So we both rotate and we revolve. So we travel a pretty far distance every single year because we're traveling around orbit around our star. So in terms of distance, we travel a pretty good ways. The circumference of the Earth's orbit is nearly 1 trillion meters. Okay, so we do travel a pretty long way. But in terms of displacement, we don't go really anywhere at all. Our displacement is actually 0. That's because at the end of a year's time on Earth, we are right back to where we started. Okay, so because we're going in this elliptical orbit, after a year, we end up in the exact same position as we started. So our displacement, or where we were displaced from our original position, is 0. So even though we traveled a really far distance, our total displacement is 0. And so now we're going to talk about what it means to describe the difference between distance and displacement. So distance is the total measured units of an object's path from start to finish. And so basically this just means it tells you how far you traveled. And this is something called a scalar quantity. Now, scalar quantities have a number but no direction. So when you're talking about distance, it's only going to be in like meters, centimeters, etc. So the units on it will not have a direction. Displacement is the change in an object's position from the starting point to the finishing point. This is a vector quantity. It has a number and a direction. Okay, so for example, if I asked you, how far did this object travel? What was the distance traveled? You could say 15 meters. That's a scalar quantity. If I asked you for the displacement of an object, you would need to say 15 meters east or west or north. It would need to have some kind of direction with it. So we would need to be able to describe the distance. So a scalar quantity is distance. Vector quantity is displacement. Okay, we'll need to commit that to memory. So again, we have these pictures here that kind of show us the difference between the two. So the distance is the total distance traveled, so the total pathway traveled. So if we're looking as we're walking along here, maybe we're taking a walk and we're winding through some woods, your distance is going to be longer than your displacement because your displacement is just the change in position. So even though it might have taken you a while and you had to wander along this path, your total displacement from your starting point might not actually be that great of a distance or great of a value. So let's take a look at an example here. It says, Bob occasionally rides his bicycle from Manhattan to New Jersey in search of discount ramen at a large Japanese grocery store on the other side of the Hudson River. Getting there is a 3-step process. 1, he has to follow the Hudson River 8.2 kilometers upriver. So he's starting out his journey to go find ramen. So he has to travel 8.2 kilometers up along the Hudson River. Then he has to cross the George Washington Bridge, which is 1.8 kilometers. Okay, so he's walked up and now he has to go over the bridge. So he's walking up and over. Then he has to reverse direction and head back down the river for 4.5 kilometers. Okay, this is all to get to the Japanese grocery store. Okay, the total distance traveled is 14 kilometers. Okay, so 8.2 plus 1.8 plus 4.5 is 14. So it's the total distance that he's traveled. But his displacement is only 2.7 kilometers north. So the end of the journey is actually visible from the start. So in terms of his traveling, his distance traveled was 14 kilometers because he had to walk 8.2, then 1.8, then 4.5. Or he's riding his bicycle, he's not walking. But he had to ride his bike in order to get there because he could not take his bicycle just across the water, right? Across the Hudson River, because it's impossible. So he has to follow the pavement and the route that's already, carved out for him. However, the displacement, meaning like where he is from where he originally started, is only 2.7 kilometers because we measure the shortest distance from where you started. Okay, so it is a difference between your distance and your displacement. The distance is the total amount that you walk, bike ride an airplane, whatever it is. It's the total amount of ground that's covered. Your displacement is just where are you in relation to your starting point. And remember, distance only comes with a measurement, so meter, kilometer in this case, and your displacement has to have a direction associated with it. So we said this displacement is 2.7 kilometers north. So when it is a displacement, you also need that directionality as well. Okay? So now let's take a look at another example. So it says, suppose a person moves 3 meters from A to B and 4 meters from B to C as shown in the figure. What is the total distance traveled by him? Okay. Well, now our distance, remember, is going to be that scalar quantity. It's going to be the total amount of ground covered, so to speak. So if we go from A to B, that's 3 meters. And from B to C, that's 4. So 4 plus 3 is going to be 7 meters, okay? And distance, again, is a scalar quantity. It only needs a value of units. So it only needs meters, kilometers, centimeters, whatever the problem is in, okay? But is he actually 7 meters from his initial position? No. The answer to that is no, because if we can see here, even though he took a longer path where he went up and then cut across, he's actually displaced from his initial position by a value of 5 meters. Okay, so even though he chose to walk the longer path, where he winds up in relation to where he started is only a value of 5 meters. Okay. And this is the shortest distance between his initial position and final position. So your displacement is the shortest path between where you started and where you ended up. Also, this is going to be a vector quantity, so it would need a direction associated with it. So technically, we would say his displacement is 5 meters in a northeast direction. Okay, so if you guys remember a compass, it's north, south, east, west. So it's 5 meters in a northeast direction. And a good way to remember that, everybody can remember north and south. But if you get confused between which way is west and which way is east, left is west. That's a good way to remember it. Left is west. Okay, so here we have another example. It says in the following GIF, if the runners just ran 400 meters all the way around the track, what was their distance? So they ran that distance. They took that, they covered that ground. And remember, distance is just a measurement of how far you've traveled. So their distance is going to be 400 meters. Okay, so they did go 400 meters. So let me go ahead and annotate. So it would be 400 meters. And then the displacement of these, pretending that they didn't run people over and stopped right at the starting line, the displacement would be 0 meters, because they are starting in the same, or they're ending in the same place they started. So the shortest distance from where they started to where they ended up is 0. Just like the example with the Earth rotating in a year, we end up in the same position that we started in. Same thing for these people running around the track. They end in the same position they started, so their displacement is 0. In this case, you don't say what direction because they haven't actually moved. Okay, so there's no displacement there at all. So that would be no displacement in that example. So a vector, just to reiterate, a vector is a value that has both a unit of measurement and a direction associated with it. Okay, so some examples of vectors are displacement, which we just talked about, velocity, acceleration, force, weight, and momentum. And those are things that we're going to be talking about in this motion unit coming up. But for today, we just need to remember displacement is a vector quantity, distance is a scalar quantity. Okay, and for vectors, again, when we're thinking about how we're traveling our displacement, 2 plus 2 does not always equal 4. Okay, so if you take 2 steps in an easterly direction and then take another 2 steps in the same direction, then yeah, you have moved 4 spaces. You have gone 4 spaces to the right, or yeah, to the right, to the easterly direction, right? So your displacement would be 4, okay? However, if you take 2 steps to the east and then take 2 steps to the west, you haven't moved any direction because you started out or you finished where you started from, so your total displacement would be 0. Okay, so just keep in mind when we're talking about displacement and distance, we have to be careful to do our displacement in relation to where we started. So distance is the total amount that has been covered. Doesn't matter what direction, you just add it all up. But displacement, you have to pay attention to where you are in relation to where you started. Okay, so that's it for distance versus displacement. We'll definitely do some practice with this, but if you have any questions, let me know.